So radiation balance at the top of the hemisphere, it says, is for the short wave, and the one below is for the long wave. Short wave means coming from the sun. So here shows the energy balance analysis of a 1-year satellite observation, averaged throughout the year for both. Shortwave radiation in the tropics is about 300 watts per meter square, but this is averaged because at a certain area or certain point on Earth at the tropic, the maximum value should be about 800 watt per meter square. But because it's averaged throughout, because sometimes we have clouds, so when you have clouds from 800, it drops down to 200, 100, and then if there's no cloud, it's 800. But you average it all out, it becomes 300 watt per meter square. So highest shortwave radiation in cloud-free regions of the ocean means there's no obstruction to light coming down. And low albedo at 0.1, that means it absorbs most of the light coming in. So that's why there's the highest shortwave radiation in the tropics. So the lowest shortwave radiation is in high albedo, 0.2 to 0, not that high, it's just slightly above 0.1, 0.2 to 0.35 in the deserts. So the highest here is, you see the red color, the deep red color, those are the highest areas for the shortwave radiation. And the lowest is where, let's say, blue or red. These are low because the curvature of the Earth makes that somewhere at the equator is the highest amount of the energy shortwave radiation received. Somewhere at the edge will be the lowest. And this is mostly because of the sun. Right? Aside from the sun, there's also the albedo, but mostly because of the sun. That's why here it's high. Shortwave radiation in the polar regions, shortwave radiation is about 100 watt per meter square average because of high zenith angle. Zenith angle is just the incident angle. Because of clouds, because of high albedo ice. Ice is white. When ice is white, it is able to reflect back the shortwave radiation. Now, long wave radiation. Greater variability in the tropics. So long wave radiation is the radiation coming from the Earth. It's more than 4 micrometer. So there's greater variability in the tropics. And because it comes from the Earth, it doesn't come from a constant source like the sun. So that's why there's variability here. It is cooler because of clouds with cold tops in the ITCZ. The ITCZ is the Intertropical Convergence Zone. So somewhere in the middle here, where all of the winds bring together the clouds into the parts. So that's why we have clouds so often over here in Malaysia, because we're right at the equator. So because of the clouds that's concentrated in the middle here, that's why we have long wave radiation to be cooler here. You see this? The one that gets reflected out? It doesn't get reflected out because of the clouds that blocks it. So here, even though right in the middle, it doesn't go back out due to the clouds. But the rest without clouds, then the long wave radiation gets removed from the surface. Okay, the highest long wave radiation comes from the deserts and equatorial dry zones. So deserts are like here in Africa, North Africa, the Sahara Desert and so on. And also other dry zones in the middle of the ocean. Even though it's the ocean, but above it, they're relatively dry. So greater variability in long wave because of it comes from the surface of the Earth, which has a very large variation of surface and cloud cover and so on. Now this is the net radiation. Now net radiation is just the short wave minus the long wave. So more input radiation at the tropics than the polar. So that means here we see that there's higher amounts of energy being absorbed because there's less long wave being removed from the Earth. There are higher long wave radiation than short wave radiation at the deserts. Over here, there's net radiation that's hot. But then because there's no cloud, there's dry, and the long wave is able to get removed straight away above. So the long wave radiation here is higher than the short wave radiation, becomes lower value net radiation here because of the surface activity of the surface. And then usually if the long wave radiation is higher than short wave radiation, it's the world's hottest region. Okay, this links back to why we study radiative transfer. It is the only way that the Earth and the universe exchange energy. And most of the energy that we have on Earth comes from the sun. So that's the main input of energy to the Earth. So if you want to do energy balance, we have to take into account of the energy that comes from the sun. And this is the only process. This radiative transfer of energy is the only process that transmit the energy from outside into the Earth. And this particular energy is the one that drives the climate, drives the weather, and that drives the pollution and so on.